Today I'm gonna to show how to debugging some example of CUDA program running on Jetson Nano board by using Nsight Eclipse running on Ubuntu 18.04 LTS running in host computer. At first, we connect Jetson Nano board by using Lamina. And we added some connection by selecting VNC and typing the IP address of Jetson Nano board. My username is WCHM and some password. Then click the connect. So we connected with Jetson Nano board. Now next one we learning Nsight Eclipse. Nsight Eclipse. I already built some CUDA application. For example, some particle example. This take maybe 1 day to succeed to build the application running on Jetson board connected remotely on Ethernet. Anyway, I shortly demonstrate how it is working and how at debugging. So you should build as a debug mode. I already built by using debug. So in this case, I just learning debug as remote application. In this dialog window, I just click the debug remote executable. Already. Click next. Sometimes this kinds of library needed for this example. Particular example, they using OpenGL, and also they using some X window graphics. So these two kinds for the paths needed. Detect root. Remotely they try to connect remotely. It's okay. Then at first they only find CUDA develop environment only. So in this case we added, click edit, and now we are connected with Jetson. In this case, the library is at root location. So click RIB, and this folder we need. Click OK, and another folder we needed. So in this case we go to USR, and go to library, and also Arch 64 Linux GNU. Okay. Maybe some documents they say this should be checked. Well, if you like check, in my case, I check this one, and remotely pass will not be validated. Then when you connect, maybe connected. So in this case, I click the next. Then they make some these kinds of debugging configuration, and they wanna launching on this debugging configuration. Okay. Now they tried learning and debugging, but this is another debug perspective switching. Yes. Then debug break occur at this line, so we must click step over, and going this one. We set a breakpoint. Go over there, and we also set some breakpoint at some display function. Where is the display function? Display function. We set some breakpoint over there. What is going on? Keep going. So they are break at some. In a previous time, I set break on this line. This file is kernel, particle kernel, some file. This macro is under the bug rubber. That means this function is called by host, and this function should be running in a GPU CUDA core. The debugging is working well. CUDA thread 000, and also in a this one CUDA. You can see the thread information. Thread thread 0, maybe this thread 0. They're using some warp 2. Warp 2 is they have 32 CUDA core. Physically, they running 32 CUDA core with warp 2. Warp is the technology, some technology, some word used in NVIDIA. Usually is set as 32 thread, 32 CUDA core running parallelly. So they called their processing architecture as a single instruction, multi-data. So 32 thread is running parallelly. Another warp, they have also 32 CUDA core or something like. But anyway, this debugging is working well. GPU, inside the GPU, this working is well. There's another variable is working well. This is working well. Keep going. Go inside somewhere. We wanna go inside. position. That one anyway. Collide sphere, maybe some sphere maybe colliding or not. They checking maybe. Only this one. Anyway, debugging is working well. So it is very easy to study, to analyze the program. There are many thread information, also register. The typical property of NVIDIA CUDA core, they have many register. Register is another fast memory near to CUDA core. So they have 256 register. Each register contain the function argument. For example, they call this function argument is maybe assigned at internal register, something like this register. So they learn very fast. Register is very fast memory type. Another memory type, fast memory type, is cache memory. Another memory type is shared memory. Another memory is just CUDA device memory. If you assign these kinds of variable as just CUDA device memory, then their learning speed is very, very slow. But if you assign this variable as in this internal register, then this function running very fast. That one anyway, debugging environment is successfully achieved. I hope these kinds of information maybe help to who wanna develop this debug environment. Okay. See you next.